Hello guys, welcome as we do the question before us. And the question is, show that the solution of the differential equation is right here, is y equals to x square root of 8x plus 1. Guys, this is what we are now going to prove, that y is equals to that. Given that y is equals to 3 when x is equals to 1. And so guys, I start off the question. To do the question, the first thing guys we are going to do is to look at the question and see how it looks like. As you can see here, we have power 2, we have power 2, and these ones, if one has power 1, the other one power 1, that is also power 2. So guys, this is a homogeneous equation. And so guys, we come and first of all divide by x squared. So after dividing, guys, this is what we have. Of course, now this is now going to be 1. And so therefore, guys, we will say, we will use the substitution v is equals to y over x. And also, x, if you differentiate v with respect to, that is y with respect to x, guys, this is what you are going to get. You are going to get dy all over dx is equals to v plus x dv dx. So guys, we come and replace our y over x with v, and we also replace dy over dx with v plus x dv dx. So we have replaced y all over x with v, and this is squared. Y over x, this is now v, and then dy dx with v plus x dv dx. So from there, guys, we are going to now put these terms on this other side, so that it shall be like this. That is 1 minus 3v squared goes to this side, and so therefore this negative becomes plus, and 1 is now negative. So from there, guys, we can now divide by 2v both sides, 2v there, and here we divide by 2v. So that now we have this now becomes 1, and now we are left with this, and then 3v squared minus 1 is divided by 2v. And then from there, this v, we can now put it on this side. Guys, remember we are trying to separate variables. After that, guys, we can come and now evaluate this. So you shall have x dv all over dx. This is now equal to, evaluating this, you shall have, you put them under the same denominator, you'll have v squared minus 1. Now, this is now going to be minus 2v multiplied by v gives us 2v squared all over 2v. And so therefore, guys, this is now going to be v squared minus 1. Guys, as you can see, this is the difference of two squares. But before we even think about that, we can now bring the like terms together, so that now v squared minus 1 over 2v comes this side, and this x comes this side. So that we shall have here x, 1 over x dx, and on this side we shall have 2v all over, here we have the dv, v squared minus 1, and we can write it in terms of v minus 1, v plus 1, because as I have said, it's a difference of two squares. Guys, with that, we can come and now integrate both sides. We integrate, but before we integrate, guys, we need to find the partial fraction for this. And the partial fraction, guys, this, I can give you an assignment. Go and try and see the partial fraction for that. But the partial fraction for this is actually supposed to be 1 all over v minus 1 plus 1 all over v plus 1. And this one now is separated. Of course, now we have to put dv here. We also put dv here, and the one that was there is okay. Even when it is like that, the one is still there. Now we integrate. Just as we would have integrated here, guys, even this one we now come and integrate separately. And this one now is integral of 1 over x dx. Now you can see it's separated. Integrating, this is now what we get. ln natural log of v minus 1 plus natural log of v plus 1 equals natural log of x plus c. Guys, we are given the condition y equals to 3 and x equals to 1. And so we can convert these ones back to v equals to y over x. And guys, I can write y, instead of writing over x, I can put under all of them under the same denominator, so that even this one becomes x. Guys, I hope you understand, because this is y over x minus 1, which when I put the same denominator, it becomes y minus x all over x plus. The same case happens to these guys. I write them under the same denominator. So instead of writing y over x plus 1, guys, I can write all of it under the same denominator, and that one means multiplying by x. That is 1 multiplying by x. Like that. This is equals to natural log of x now plus c. Guys, this is our equation now. Now I can place 3. So if I put 3 for y and x for 1, this is what, guys, I will get. This comes to natural log of 2. Because when you put 3 here, 3 minus 1 is 2, and this is 1. And this is natural log of 4. It's equals to natural log of 1, log of 1 plus c. Guys, we are looking for c. So this one now is 0. And the log of 1 to any base is always 0. And so, guys, apart from getting our equation right here, we are able now to get even the value of c. And so I can write the whole equation now, how it is supposed to look like. And so, guys, this is our equation. And now we want to make y the subject of the formula. As you can see here, we have y equals to x square root 8x plus 1. Guys, this is what we are now going to do to make y the subject of the formula. And guys, now this is where we now use the laws of indices, or the laws of logarithm, such that this one now becomes natural log of, now from logarithm, now we are supposed to multiply this. So when we multiply them, guys, as you can see, this one is a different, brings about difference of 2 squares. So this is y squared minus x squared all over, this one now becomes x squared. All that is now equal to, we also multiply this, is natural log of 8x. And so therefore, both sides now are the same. This is the same as that. So you have y squared minus x squared all over x squared equals to 8x. Guys, I want to give you an assignment. This is just about finding the subject of the square. Please try and see whether you can get the subject of the, not of the square, but of y. Given this equation, guys, are you able to get the subject, to make y the subject of the formula? Let's see, guys, whether you shall be able to do it. For me, let me just go ahead and write this solution, because I I am sure that this will bring about y is equals to x square root 8x plus 1. Guys, go and try it and see whether this will bring this when you make y the subject of the formula. And guys, I believe it shall come to this. So guys, thank you for listening to me. Bye.